This session is about expressing concentrations of solution. What is a solution? A solution is a homogeneous mixture of two or more than two components. And these components are termed as solute and the solvent. So if a solution is made of a solute and a solvent, that is only two components, that solution is known as binary solution. So in class 11th we'll be talking about binary solutions. Binary solutions are those solutions which are a homogeneous mixture of two components, solute and the solvent. Now what is a solute? The component which is present in lesser amount is the solute, and the component which is present in larger amount is the solvent. For example, if we dissolve 20 milliliter of ethyl alcohol in 80 ml of water, then in that case ethyl alcohol is solute, present in lesser amount 20 ml, and water will be the solvent, that is 80 ml, present in larger amount. So solute is that component of the solution which is present in lesser amount, and solvent is that component of the mixture which is present in larger amount. Now let's see what is the meaning of concentration. Concentration means amount. The meaning of concentration is amount, or in chemistry we use different methods for expressing the amount of solute present in a definite quantity of solvent. So we can say concentration means amount of solute present in 100 gram of solvent, or we can also say present in a definite quantity of solvent. So we'll see now what are the different methods of expressing concentrations of solutions. Like first method is mass percent. Mass percent. This term mass percent is expressed in terms of percentage, and it may be defined as the number of parts by mass of solute per 100 parts by mass of solution. Per 100 parts by mass of solution. So that is called mass percent, or the mass of solute per 100 gram of the solution may also be called as mass percent. This mass percent can be calculated using the formula mass percent is equal to mass of solute. Mass of solute upon total mass, that is mass of solute plus mass of solvent into 100. So this is the formula for calculating mass percent. Mass percent is equal to mass of the solute divided by total mass into 100. This may also be written like this: mass percent is equal to WB upon WA plus WB into 100. So what is WA and WB? WA represents the mass of solvent, and WB represents the mass of solute. Okay, so these terms may be replaced by WA and WB. So formula can be further simplified as mass percent is equal to WB upon WA plus WB into 100. So with the help of this formula, we can easily calculate the mass percent of the solution. For example, if we say that this is 20 pi. If suppose you find somewhere written like that, 20% solution of NaCl. Now what does it mean? 20% solution of NaCl means 20 gram of NaCl present in 100 gram of solution, or we can say present in 80 gram of water. So this is how we can represent mass percent. Next method is volume percent. Volume percent means the amount of solute in milliliter present in 100 milliliter of solution. So formula for volume percent can be written as volume of solute, that is WB, upon volume of solution, that is VA plus VB multiplied by 100. So this is the formula for representing volume percent. When a solution is expressed in volume percent, it is written as V by V solution. For example, a V by V solution, or we can say a 30% V by V solution of ethyl alcohol. What does it mean? It means that 30 milliliter of ethyl alcohol is present in 100 ml of solution, or we can say is present in 70 milliliter of water. So this is how we can represent volume percent. So volume percent, a solution which is expressed in terms of volume percent, is indicated by the symbol V by V, and a solution which is represented in terms of mass percent is represented by W by W. Third method is molarity, which is represented by capital M. It may be defined as the number of moles of solute present in per liter of solution. So molarity may be expressed as number of moles of solute upon volume of solution in liters. Now molarity may also be written as number of moles is expressed with the help of letter N, and solute is represented with the help of letter B. So number of moles of solute is NB and volume of solution in liters. So molarity may be represented by the formula NB upon V. Further, number of moles of a solute can be calculated by using the formula given mass upon molar mass. Given mass upon molar mass. Given mass means WB and molar mass means MB. So NB can be also represented by WB upon MB. So NB can be replaced by WB upon MB into volume in liters. So this is the formula for calculating molarity of the solution. The unit of molarity is mole per liter. Mole per liter, or it is also written as simply M. It is also represented by simply M. Now the fourth method of expressing the concentration of solutions is molality. Molality, which is represented by small m. And molality may be defined as the number of moles of solute present per kg of solvent. So this is the difference between molarity and molality. Per kg of, it is expressed in terms of per kg of solvent, whereas molarity is expressed in terms of per liter of solution. So molarity is equal to number of moles of solute, that is NB, upon mass of solvent, that is WA in kg. And this NB can be replaced by WB upon MB, mass upon molar mass of solute into WA in kg. So this is the formula for calculating molality of a solution. Now see, one difference which we see between molarity and molality is that molarity is expressed in terms of volume of solution per liter, and molality is expressed in terms of mass of solvent in kg. Now if we increase or decrease in temperature, the volume may be affected but the mass is not. On increasing or decreasing temperature, volume may also increase or decrease, but there is no effect on mass on increasing or decreasing the temperature. Therefore, molarity changes with change in temperature, but molality, which is a function of mass, do not change with change in temperature. So which is a better method of expressing concentration? Molality is a better method of expressing concentration because it is independent of temperature and do not change with increase or decrease in temperature. Next method of expressing the concentration is mole fraction. It is represented by a Greek letter chi, C-H-I, or which looks like X. We may also say X, or we may pronounce it as chi. So mole fraction, it represents the number of moles of a component to the total number of moles, or we can say mole fraction may be defined as the ratio of moles of a component to the total number of moles. For example, if we have to calculate the mole fraction of a solute B, let us say chi B, then it will be equal to the number of moles of the component B upon total number of moles, that is Na plus Nb. So for a binary solution, chi B may be calculated using this formula. Chi B is equal to Nb upon Na plus Nb. Further, Na can be calculated by using the formula mass upon molar mass. And Nb can be calculated by using the formula mass of solute upon molar mass of solute. And if we have to calculate the mole fraction of the component A, in that case it will be equal to ratio of mole fraction of A upon total number of moles. So both the mole fraction of both the components can be calculated by dividing the number of moles of the component with the total number of moles. One more thing, the sum of mole fractions of various components in a solution is always equal to 1. So chi A plus chi B is equal to 1. This is another method of expressing mole fraction. Now since it is also depending on mass only, therefore it is also not affected by temperature.